Hello, may I audible?
Yes, sir.
Okay.
Sir, shall I start?
Yes.
So, first of all, good morning, all the dignitaries and my dear colleagues and students. Good morning, to one and all. So today, I would like to myself, Sheikh Abdul Karim. I'm working as assistant professor in Chalapathy Institute of Technology. Now, I would like to give small intro about today resource person, Dr. Chandresh Solanki Garu. He is a faculty member at SVNIT Surat since 1991, and he guided 25 PhD theses and 64 postgraduate dissertations. And he presents research supervisor of 6 ongoing PhD research scholars and published more than 220 research papers in reputed international, national journals and conferences. And he got 6 design patents, and he reviewed more than 100 research papers of reputed journals, conferences, and delivered more than 65 expert lectures. And he published 10 books and edited proceedings, and he received Sri M.S. Jain Biannual Award for Best Paper in IGC 2013, Professor Dinesh Mohan Award in IGC 2017, and the Distinguished Faculty Award from the Venus International Faculty Awards 2016. And he received many Best Paper Awards in different conferences, and he organizes more than 30 national level events, including STTPs, FDPs, conferences, seminars, and webinars. And he is chairman of Indian Geotechnical Conference IGC 2019 Surat, and he elected as member of Executive Committee of Indian Geotechnical Society for 4 terms 2015 to 2021, and he worked as Dean Planning and Development and head of the department at SVNIT Surat. He is selected as a member of a special technical committee tall building by Government of Gujarat, nominated to represent the Indian Geotechnical Society as a corresponding member of International Technical Committee. He served as member of Technical Committee of International Society for Soil Mechanics and Geotechnical Engineer for Geoengineering Education. Now I wish to hand over this session to today resource person. I request Professor C.H. Solanki Garu to start this section.
Okay, thank you for your introduction.
Thank you, sir.
May I audible to you?
Yes, sir.
I am thankful to the organizer for inviting me to meet you all on this occasion of the webinar. And I am just sharing my slides here. Okay, can you see my slides here?
Yes, sir.
Okay, thank you. So, as mentioned in the poster of webinar, my topic of presentation is soil investigations for foundation of structures. As you know that geotechnical investigation program should be such that it can be ascertained that the foundation system is safe, where shear failure of soil should not have to be occurred. It means that the shear stress on the soil mass should not exceed the shear strength of the soil. Excessive settlement of the soil should not have to be occurred. It means that the foundation settlement should be within permissible limits given by the Indian standard codes for the different soils and different foundations. We are supposed to know the susceptibility of the liquefaction based on the strata at the foundation depth as well as below the foundation. The geotechnical project sequence consists of the site research, field reconnaissance, field exploration, laboratory investigations, geotechnical interpretations and analysis, and report of explorations. Some common objectives of the soil investigation, which are pointed here. One is identify and describe the pertinent surface conditions. Second is to determine the location and thickness of the soil and rock strata. Third is determine the location of the groundwater table. Fourth, recover the samples for laboratory testing, conducting the laboratory and field testing, and identify the special problems and concerns. Geotechnical investigation would consist of what? Here I have pointed out something here. How to decide the number of test bores, how to decide the depth of the exploration of the test bores, what are the field tests to be conducted in general, what are the laboratory tests to be conducted, and correlations of the field and laboratory test data for determination of the safe bearing capacity. Preliminary, as per the Braja M. Das book, Principles of Geotechnical Engineering, it is said that no hard and fast rule exists for determining the number of borings or depth up to which borings are to be advanced. But some of the guidelines for deciding the number of borings are mentioned here. The conventional wisdom says that the number of borings will be increases as the soil variability increases. As the load increases, or for more critical and significant structures, the number of borings will require more. Whereas the thumb rule says that in case wherever you are dealing with the soft soils, the spacing between the bores may be 100 feet to 200 feet. Whereas as the soil becomes harder, the spacing increases up to 500 feet. This indicates that when you are dealing with the weak deposits, you may have to go for the more number of borings in compared to whenever you are going for the hard soils. How many borings will go for which type of the projects and in which type of the soils? So here the two types of the project has been mentioned here. One is the highways upgrade and second is multi-story buildings. As far as the subsurface variability is concerned, the soil has been divided into the three groups: irregular soils, average soils, and uniform soils. So it is suggested that whenever you are dealing with the uniform soils, you may have to go for 1/4 number of boring in compared to wherever you are dealing with the irregular soils. How many borings will go for the area? So here for the different subsurface conditions, it has been suggested that whenever you are dealing with the erratic surface, you may have to go for the more number of borings. Whereas whenever you are dealing with the high quality and uniform soils, you may have to go for the less number of borings. Number of test bores. As per IS 1892, clause 2.3.1, for a compact building site, covering an area of 0.4 hectare, one borehole or trial pit in each corner and one in center should be adequate. Here it has been presented that whenever you are dealing with the rectangular plot area of 4,000 meters square or more, you may have to go for the 5 boreholes, one in the center as well as one in the each corner. But whenever for smaller and less important buildings, even one borehole or trial pit in center will be sufficient. So this shows that whenever you are dealing with the small plot area, sometimes one borehole is enough. May I audible to you clearly?
Yes, sir. Yes, sir.
Thank you, sir. And my slides are clearly visible. Can you see my slides while I am rotating?
Slides are very visible, sir.
Okay, thank you for confirmation. Since soil is highly heterogeneous, some reference books suggest as under. Even in case of the plot area around 3,000 meters square, sometimes you may have to go for the 5 boreholes. Whereas, whenever you are dealing with the plan area of around 3,000 meters square, and your area is the square plot area, in that case, you may require less number of borings in compared to the rectangular plot area. As these corners are away from the center in case of the rectangular plot area, whereas in case of the square plot area, the center and corners are closer. In such cases, you may select these positions of the borings. However, whenever you are dealing with the area of around 3,000 meters square or so, you may not have to go for the 5 bores every time. But for ordinary buildings, investigations can be limited to economize in money and time, and 2 test bores may be taken across the site. In case of the ordinary buildings, 2 test bores are sufficient as mentioned here. If soil is highly variable, in such cases, the additional test bores are being required. Here, when area is to be investigated is large and plant layout is not finalized, the area may be divided into the grid of suitable size and test points taken on grid corners. So here, whenever you are dealing with the large area, you have to divide it into the number of grids, and the corners of the grids has to be selected for the point of boring. But what to do in case whenever the structure layout has been finalized? So where the structure layout has been finalized, the test points may be taken to correspond with all the important building units. Important building units means wherever you have heavy column has to come, wherever you have staircase has to come, wherever you have heavy machinery has to come, you select the such points as a point of borings. For various structures, how will you consider the number of bores? It has been mentioned here in this slide. So serial number 1 to 6 showing the types of the structures and what number of test bores are required for such structures. As you know that the lightweight utility structures like parking sheds, watchman cabins, etc. does not require the full borings. In such cases, one of the trial pit of shallow depth may be sufficient. Whereas in case of the residential building, of low-rise building, 4 to 5 story building, the 2 test bores are sufficient. In case some adverse conditions, if you require some more borings, you may go for. However, it has been suggested that in case of the multi-story building, you must go for the 5 number of boreholes. In case of the industrial plants, site can be divided into the grid of suitable size and test bore taken at each grid corner. An additional test bore or plate load test may be taken for important structures like chimney, etc. As far as the elevated storage reservoir are concerned, you must go for the minimum 1 borehole. Whereas, as far as the bridges are concerned, you must have to go for the boring at each pier and each abutment. This we have been discussed about how will you select the number of borings. Now we are coming to how will you select the depth of the test bores or depth of the exploration in case of the soil investigation. The depth of the test bore should extend up to a point at which the vertical stress due to the proposed structure is equal to or less than 10% of the original effective stress at the point before the structure is constructed. Normally, it should be 1.5 times the width of the footing below the foundations. In general, we are going for the depth of the exploration up to a depth 1.5 times to 2 times the width of the footing below the depth of the foundations. But in case of the adverse conditions, we may have to go for the deeper depth of the explorations. How deep you will go for in case of the different subsurface conditions? It has been presented here in this slide. If your strata is poor, average or good, in such cases, S indicates the number of story and D indicates the anticipated depth of the foundations. Based on that, you can decide the depth of the boring. How deep you will go for the bridges? What are the factors to be considered in exploration or in deciding the depth of the exploration for the bridges? Here it has been mentioned that boring depth is governed by various factors, including 1, foundation type, 2nd, foundation load, 3rd, scouring, etc. Here it has been mentioned that, generally speaking, 50 feet to 80 feet is reasonable, but local experience is helpful. Look at the nearby structures if available, and if no experience or other information is available for the particular site, plan for a long first hole and then adjust. How many borings and how deep you will go for? George F. Sauer in his book of Introductory Soil Mechanics and Foundation has been mentioned that the final engineering can be no better than the data upon which it is based. It indicates that you should have your own data for your sites. You cannot use the results of the nearby site which has been conducted previously. The depth of the exploration at the start of the work may be decided as under. So how will you decide the depth of the exploration for the isolated footing, raft, pile and well foundation? It has been mentioned here in this slide. Now, this we have discussed about whenever you are going for the soil investigations, how will you select the number of boreholes? as well as how will you select the depth of the explorations. Now we are coming to what are the field tests to be conducted at the site. The most widely used method of subsurface investigation is boring holes in the ground and simultaneously conducting the standard penetration test and collecting the undisturbed samples. However, sometimes due to the site constraints, time constraints, importance of the project, erratic subsurface data, or to supplement the data obtained from the test bores, additional field tests are being required. This slide shows what are the tests to be conducted in the test bores. The test which can be conducted in the test bores, which has been mentioned in the column number 2. These tests are standard penetration test, undisturbed samples, in situ vent shear test, core cutter, pressure meter test, and permeability test. These tests which has been mentioned in the column number 2 are to be conducted in the test bores. In the third column, what is the applicability of the such test? It has been mentioned. In the fourth column, by conducting this field test, what are the informations available as a part of the results or interpretation from the test? It has been mentioned. In the last column, what precautions has been required in performing the test? It has been mentioned here. Now, what are the tests to be conducted in the trial pits? In the previous slide, we have seen that these tests were being conducted, or these tests are being conducted in the test bore. Whereas in this slide, it shows that which tests are being conducted into the trial pits. So it has been mentioned that undisturbed samples can be conducted in the trial pits. Plate load test can be conducted in the trial pits. Dynamic test. This part of the dynamic test has been described in IS 5249, where the two methods has been described in the detail. One is the cyclic plate load test, and second one is the block vibration test. So how to find out the coefficient of the elastic uniform compression, which is being used for the design of the machine foundation? It has been described in this IS 5249. And field CBI test can also be conducted into the trial pits. As mentioned in the last slide, the third column indicates what is the applicability of the test. Fourth column indicates that what are the informations available by conducting this test. And last column indicates that what precautions to be taken in performance of such test. Okay. Now we are coming to the in situ testing. When it is difficult to obtain the undisturbed samples, in such cases, in cohesionless soils as well as sensitive clays, we are mostly going for the in situ test methods, and we have to rely on the results of the in situ test methods. Generally, in case of the cohesionless soil, the results obtained from the standard penetration test are being interpreted for the foundation design. Whereas vent shear test is mostly useful in case of the very soft clay as well as the marine clays. These clays are very sensitive. You may be aware of the standard penetration test. What is this test and how it is being conducted? We are using the hammer of 63.5 kg height of the pole of hammer is 76 centimeter. We are driving the split spoon sampler into the hammer, using the hammer into the test bore for 45 centimeter. 45 centimeter means it is 18 inches. So first 6 inch we are considering as a seating drive, whereas for the next two segment of the 6 inches, what number of blows is being required to drive the split spoon sampler into the soil, it has been noted. And summation of both has to be made, and which is known as the standard penetration value. In geotechnical engineering, we call it as a capital N value. This is a split spoon sampler which has to be penetrated into the soil in the test bores while conducting the SPT test. This is the arrangement, manual arrangement of conduction of the SPT test. You might have seen in the textbook or while studying this. These are the different hammers may be used for driving the sampler into the soil. Now, you may be familiar with the disturbed samples and undisturbed samples. Disturbed samples are particularly useful for the mechanical analysis, such as the sieve analysis, hydrometer test, determination of the water content, index properties, compaction test, etc. So disturbed samples from the site has been collected to perform this laboratory test. Whereas undisturbed samples are very significant in performing the strength test as well as the compressibility test. So mostly the strength and compressible parameters which we find in the laboratory, we are using the undisturbed samples or the remolded samples. Now, we have been already discussed about the split spoon sampler and all. What are the inside clearance, outside clearance, and area ratio for the split spoon sampler? It has been mentioned here. Now, here, this is very important slide. N value, which we are finding out by conducting the SPT test. It should be noted that the standard penetration test is currently most important or popular and economical means of obtaining the subsurface information, both on the land and offshore. It is estimated that 85 to 90% of the conventional foundation design is made up using the standard penetration test N value. The N value has been used in correlation for unit weight gamma, relative density dr, angle of internal friction phi, and undrained compressive strength Q. As you know that, as far as the sand is concerned or cohesionless is concerned, we do judge its properties based on the relative density and angle of internal friction. Whereas in case of the non-cohesive soils, we are finding out the undrained compressive strength to know the cohesion of the soils. The angle of internal friction phi and cohesion C help us in determining the bearing capacity of the soil. So N value help us in finding out these values by the correlations. This chart you might have seen in many of the textbooks where N value correlations have been shown. Okay, may I audible to you, sir?
Yes, sir, you are audible, sir.
And presentation is going okay? Is these slides are okay, which you can see?
Okay, sir.
Fine, value. Here the slide shows the N value correlations. For cohesionless soils, the N value has been kept here in the range of 0 to 50 or more than 50. Whereas for cohesive soils, the sum N value has been presented here for the different soils. First, we discuss about the cohesionless soil and interpretation of the N value for the cohesionless soil. So it has been mentioned that here, as far as this table is concerned, the cohesionless soil has been classified into the 4 soils: loose sand, medium sand, dense sand, and very dense sand. So based on the N value, what may be the relative density of the soil, it has been presented. It has been said that if relative density of the soil is in the range of 0 to 15, the soil is very loose. If relative density of the soil is in the range of 15 to 35, soil is loose. If relative density of the soil is in the range of 35 to 65, the soil is medium dense. And if relative density of the soil is 65 to 85, soil is dense, and greater than 85, soil is very dense. Here it has been shown that if relative density of the soil is less than 35, in such cases, fine saturated sand, which is having mating with the water table, in such cases, the chances of the liquefactions are higher due to the dynamic loading. Whereas the angle of internal friction has also been correlated here with the N value. So you may see that as far as the N value is 0 to 2, the angle of internal friction is limited to the 30 degree. Whereas in case of the N value 30 to 50, the angle of internal friction is about 36 degree. Slight increase in the angle of internal friction increases the bearing capacity larger once it reaches to the 30 degree. Slight change in the angle of internal friction showing the great reflection in calculating the bearing capacity. Whereas the cohesive soil has been divided into the different description here for the different range of the N value. So when you call the soil as a soft clay, hard clay or medium clay or stiff clay, it has been mentioned here on the basis of the N value. In the last slide, I have been presented that 85 to 90% of the foundation design is on the basis of the N value. Slide are being used to find out the safe bearing capacity of the soil or the ultimate bearing capacity of the soil. And that's why these parameters can be used for that purpose. Hence, this sentence has been presented. Now, the sum of the how to consider the factors affecting the SPT block-out. It has been mentioned in the IS codes. What are the factors to be taken into the consideration in correction of the SPT value? In addition to the dilatancy correction and overburden corrections, hammer efficiency, borehole diameter, type of the sampler, road length, etc. Use of SPT data is being used for finding out the relative density, angle of internal friction and cohesion. It has been presented in the previous slides. Now we are coming to the cone penetration test. Originally developed in Netherlands in 1930s, further development in the 1950s, which is also known as the Dutch cone. The STM D3441 described the procedure for the same. And types of the CPT devices which can be used may be mechanical con, electrical con, or the piezo con. These are the mechanical cons, electrical cons, con penetrometer. This is the truck mounted arrangement for conducting the con penetration test, CPT truck. Now from con penetration test or static con penetration test, we mainly measure the con resistance. It is also known as the bearing resistance or the tip resistance, and sleeve resistance, which is also known as the frictional resistance. So typical CPT results has to be put in these formats. The first figure shows the side friction. The second one shows the penetration resistance. But while conducting the static con penetration test, it is not being conducted in the test bore. It has to be directly, the con has to be directly penetrated from the surface of the ground. Hence, we do not get the type of the strata. That's why simultaneously boral requirement is there. We are supposed to know what is the type of the soil and what is the position of the water table while interpreting the data of the side friction as well as the penetration resistance. This slide shows the use of CPT data and how it is being used. So con bearing versus friction ratio has been shown. And what is the type of the soil? It has been presented here on the basis of the resistance we obtain. Wensleydale test. This is specially suited for the soft sensitive clay. It is a quick test used to determine the undrained shear strength. The test is particularly preferable in the soft clay or marine clays. The test has to be conducted into the test bore. We have to insert the vane, rotate the head into the test bore at the required depth, measure the torque at which the soil fails, and relate the resistance to the soil shear strength. So whatever the torque at which the soil fails you are measuring, based on that you can get the shear parameters of the soil or the cohesive soils. Now whatever test we have been discussed here, you can compare it for the different points. Which one is simple? So simplicity and ruggedness, ease of testing, resolutions, basis for interpretations, types of the soils, equipment availability, and potential for future development. You can compare for your sites and you can take the decision for performance of the test. Groundwater monitoring is being required. Groundwater level must be determined during the geotechnical exploration. Measure at the time of the drilling and later after 24 hours. And can be accomplished by leaving the selected soil borings open or install a piezometer for measurement of the groundwater table. This is showing you the SPT automatic trip hammer. Now, what are the advantages of CPT versus SPT? It has been mentioned here. The advantages of CPT versus SPT are those which provide the much better resolutions and reliability. Versatility, pore water pressure and dynamic soil properties can be determined in case of the CPT test. Whereas the disadvantage of the CPT test are here mentioned here, does not give a sample, will not work with a soil with gravel, and need to mobilize a special rig. Special equipments are being required in performance of the static con penetration test. Field CBR test is very important. This is the guiding parameter for the design of the flexible pavements. Evaluate the strength of the subgradient basis for roads and runway pavements. The ratio of the force per unit area required to penetrate a soil mass with a standard circular piston at the rate of 1.25 mm per minute to that required for corresponding penetration of a standard material. So California bearing ratio is being useful and guiding parameter in the design of the flexible pavement. This is the performance of the test. Plate load test, as mentioned earlier, determination of the ultimate bearing capacity of the soil in a plate, which assume that the soil strata is reasonably uniform, and also used to find the modulus of substrate reaction. The test results reflect only the character of the soil located within the depth of the less than twice the width of the bearing plate. As you know that the size of the bearing plate is 1/5 of the size of the foundation or width of the foundation. Since the foundations are generally larger than the test plates, the settlement and shear resistance will depend on the properties of much thicker stratum. This is the arrangement of the plate load test. Here we have seen what are the field tests to be conducted at the site in general, balancing cost and risk. The scope of a subsurface exploration for any particular site is a difficult problem which is closely linked with the relative cost of the investigation and the project for which it is undertaken. In the book of the V.N.S. Murthy in Geotechnical Engineering, this statement is given. Now, after conducting the laboratory test, we'll have to go for the, after conducting the field test, we'll have to go for the laboratory testing. As most of the students are attending, I have presented here what are the tests to be conducted in the laboratory. I'm trying to discuss the significance or applicability of the test. Which test results are to be useful where? So you may be familiar with this test which has been presented here. Moisture content, unit weight, sieve analysis, Atterberg limits, compaction, hydraulic conductivity, consolidation, direct shear test, triaxial test, unconfined compression test, etc. Now, first, whenever you started studying the subject of the geotechnical engineering, you might have studied the weight-volume relationships. You may have studied the phase diagram of the soil, and you may have understood the three-phase system of the soil and two-phase system of the soil. Where you have studied the different parameters studying the weight-volume relationships, such as the different unit weights of the soil, known as the bulk unit weight, dry unit weight, saturated unit weight, submerged unit weight of the soil solid, etc. In addition to that, you have studied the void ratio, porosity, specific gravity, etc. So here, which parameters has to be used where and for what purpose? This has been mentioned on the right-hand side of this slide. You also studied the plasticity characteristics in the form of Atterberg limits. You are familiar with the Atterberg limits in the form of liquid limit, plastic limit, as well as shrinkage limit. These Atterberg limits are useful to us to know the soil indices. The various soil indices can be determined on the basis of the Atterberg limits, such as the plasticity index, liquidity index, consistency index, activity number, etc. We can come to know by performing the Atterberg limits. The tests are mostly useful. Test results are mostly useful in studying the field behavior of the fine-grained soil. We can also denote the degree of firmness of the fine-grained soil by knowing the Atterberg limits of such soils. Gradation characteristics you might have studied in the particle size distribution curve after getting the performance of the sieve analysis test and the hydrometer test. You are drawing the particle size distribution curve. From that, you are going to find out the various diameters, D10, D30, D60, D85, etc. So these are being used for classification of the soil as well as the design of the filter in case of the dams. We can also find the permeability of the soil knowing such parameters. I lost the connectivity and I have come back. Is it okay for you now? Hello? Hello? Hello, may I audible to you? Hello? Hello, may I audible to you?
Yes, sir. Audible, sir.
Okay, I had lost the connectivity and I have come back now. Sir.
Yes, sir. Now audible, sir.
Okay, fine. So the consolidation settlement is being determined on the basis of the compression index and coefficient of the volume change, depending on the whether soil is normally consolidated or over consolidated. So CC parameter is being used for normally consolidated soil to calculate the consolidation settlement, and MB parameter is being used for over consolidated soil to find out the consolidation settlement of the soil. And here the parameter which has been shown here, it is the coefficient of the consolidation. This parameter is being used to know the time rate settlement. How long will it take? It can be determined on the basis of the CV. In the textbook of the geotechnical engineering, you might have studied the two methods of finding out the CV. One is the square root time fitting method and second is log time fitting method. Now we are coming to the strength characteristics. We have already seen the significance of the angle of shearing resistance phi, cohesion C. These are the shear parameters. In addition to this, unconfined compressive strength is also useful in case of the clay soil to know the cohesion of the soil. These strength parameters are being used for the analysis of the stability and load carrying capacity based on the strength. Blow count of SPT, we have understood the significance of it and what are the correlations. The bearing capacity factors which are being used in the equation of the bearing capacity, these are being determined from the angle of internal friction phi. The various researchers have given these bearing capacity factors depending on the angle of internal friction phi. And sensitivity is what? So estimating the effect of the disturbance of the structure on the strength of the soil, it is known as the sensitivity. The compaction parameters is being used in the earthwork or the embankment work. We need to know the optimum moisture content and maximum dry density for the site where we are working. These parameters has to be determined in the laboratory, and with the same parameters, we have to work in the field with the controlled earthwork. What are the IS codes are being used for the different tests? It has been presented here in this slide. This is the laboratory test, how it has been conducted. Now we are coming to the information which is being obtained from the field as well as which is being obtained from the laboratory, how it has to be presented. The results obtained from the field and laboratory has to be presented in the form of the bore log. So here, what are the tests to be conducted as a part of the sounding test? Some of the tests has been discussed here in this presentation. How to find out the field dry density, moisture content, you may be familiar with this. You are also familiar with the particle size distribution curve. You also knowing about the consistency limits and its significance. You also know about the shrinkage limit and classification of the fine grained soil using the A-line chart. How the soils are being classified, and what are the different types of the soils as far as the fine grained soil is concerned in terms of the clay and silt, whether it is highly compressible, medium compressible or low compressible, it has to be obtained from the A-line chart. Specific gravity determinations, shear parameters has been shown here. You may be familiar with this. As far as the swelling characteristics of the soil is concerned, we are supposed to know the shrinkage limit of the soil, free swell index and swelling pressure test results. If these results we do have, in such cases, we can come to know about whether the soil is expansive or not. The equations which has been shown here in this slide, these equations are for determining the bearing capacity of the soil. This is given in IS 6403. As shown to you earlier, NC, NQ and N gamma are the parameters known as the bearing capacity factors. It has been determined from the angle of shearing resistance phi based on the tables available. SC, SQ and S gamma are known as the shape factors depending on the width and length of the foundations. DC, DQ and D gamma are known as the depth factor depending on the depth and width of the foundations. And IC, IQ and I gamma are known as the inclination of the load factors. In addition to this, how to consider the position of the water table, does it affect or not? It is given in the form of water table correction factor as W dash in this expression. You may have to find out the bearing capacity by considering the soil types. In case of the loose and very loose sand, soil comes under the category of the local shear failure, whereas the dense and very dense sand comes under the category of the general shear failure. Similarly, soft and very soft clay comes under the category of the local shear failure, whereas the steep and hard clays comes under the general shear failure. So considering this, we need to calculate the bearing capacity of the foundations. Here, how to calculate the shape factor, depth factor, and inclination of the load factor, this has been presented here. So it has been presented how to find it. The presentation which has been made just now in the form of the slide, it shows the field part, the test which has been conducted in the field, and how the results has been obtained in the field has to be presented in the bore log. So this is showing that up to 10 meters the bore log has been presented. It does indicate that the depth of the exploration is 10 meters. Description of the strata has to be presented in terms of the visual inspection. While investigating the site in the field, you are observing the soil by taking in your hand, and you need to describe the soil, what you observe. The next column is showing the soil types, which comes after the laboratory results and detailed soil classification. Then we do have what is the position of the water table. It has been marked here. In this column, the different terms are being marked in terms of DS, that is disturbed samples, in terms of UDS, that is undisturbed samples, and in terms of SPT, that is standard penetration test number, that is the N value. So what are the results obtained at which depth? The corresponding depth has been mentioned in the next column. What is the N value in the field? It has also been presented here, corresponding to the SPT test, the depth at which it is mentioned. So based on this, the field results are being kept here. In continuation with this, the laboratory results are to be presented in the bore log. The laboratory results are being presented in this form. The OMC and MDD is being presented. For all the bore logs, these test results may or may not be. Wherever you have to go for the earthwork, the results of OMC and MDD are must. But sometimes we do not find these results in the bore log, whereas the grain size analysis has to be presented for all the bore logs. What are the percentage of the gravel, sand, silt, and clay? It has to be presented in these columns. In addition to this, what are the Atterberg limits? The samples which you have been tested in the laboratory, what are the liquid limit, plastic limit, and plasticity index for such soils? It has to be presented in the form of Atterberg limits. Once you get these results, you will be in a position to get the classification of the soil, whether the soil is coarse grain soil or fine grain soil. You can classify using this data. In addition to this, as we know that the results obtained from the field test as well as the laboratory test, we are using for the bearing capacity computation. So we need to have to mention about the shear parameters at the different depths. In addition to shear parameters, if you are conducting the test on the consolidation saturated clay soil, you need to have the results for the consolidation parameters too in the bore log. So here, as far as the previous slide is concerned, and this slide is concerned, in continuation of the previous slide and this slide, both the slides are presenting what are the results obtained from the field results as well as the laboratory results. In the table which has been given below in this slide, which shows that the computation of the safe bearing capacity. Now for the different size of the foundations and at the different depth, the safe bearing capacity is being computed using the IS 6403 equations, and results has been presented here. Now, whatever part I've been shown to you here is, we have information regarding type of the structure and total loads coming on the foundation should be given to the agencies carrying out the geotechnical investigations so that the depth of exploration may be modified during the course of investigation. If sufficient bearing capacity is not available at the required or estimated depth, number of test bores should be adequate to get the horizontal as well as vertical profile of the subsoil strata. For each strata encountered, following data should be available: N value, bulk density, natural water content, shear parameters, consolidation parameters, swelling parameters, and classification of the soil. Undisturbed samples and SPTs should be staggered in test bores. And if SPT is conducted at 1 meter test in borehole number 1, it has to be conducted at the 2 meter depth in the borehole 2. Likewise, the staggered performance of the SPT at the intermediate depth has to be done. Now we are coming to the one of the problem in which I am going to explain you how to find out the allowable bearing pressure. Till now we have seen that how to compute the safe bearing capacity. But now we are coming to the part by which we are going to understand that how to compute the allowable bearing pressure. Allowable bearing pressure is the net loading intensity at which soil neither fails in shear nor there is an excessive settlement detrimental to the structure. Based on that, one of the problem has been taken from the book of Professor Satyendra Mittal, The Soil Testing for Civil Engineers. The industrial building in central India has to come up. The three-story structure is there. Type of foundation suggested is rough. Size of the foundation is 12 meter by 7.5 meter and depth is 1.5 meter. This is the borehole detail given in the data. In this borehole, the type of the soil at the different depth has been given. Where the UDS test has been conducted or where the UDS sample has been taken, it has been presented. Where the SPT test has been conducted and what are the values, it has also been presented. What is the foundation level? It is also being presented. It has been presented that the least lateral dimension of the foundation is 7.5 meter. Hence, the influence zone or the depth up to which the exploration has been made, it is 11.25 meter. 1.5 times of the 7.5, and that's why total depth is coming out to be 13 meter depth of the exploration. In addition to this, the shear parameters at the different depth has been shown here in this borehole detail, which has been presented. So influence zone has been 11.25 meter. The depth of the foundation has been located as 1.5 meter. So total depth of the exploration is taken out around 13 meter. Groundwater table position is 5.5 meter below the ground level. Cohesion value is 3 ton per meter square and phi value is 8 degree. Specific gravity of the soil is 2.65 and water content is 8.75%. Here it has been presented in the data that the compression index has to be taken as 0.11. So what is the thickness of the each stratum as far as the soil types is concerned? It has been presented here and which has been shown in the form of CL soil of 3.5 meter thickness, MLCL soil of 1.5 meter thickness, SM soil of 4 meter thickness, and CL soil of 2.25 meter thickness. Now, as far as this data is concerned, how to get the values of NC, NQ, and N gamma based on the phi value, it has been presented. How to consider the method of analysis based on the relative density and void ratio has been presented here for the case of local shear failure and general shear failure. How to compute the shape factors? It has been presented here. How to compute the depth factors and inclination of the load factors in computation of the bearing capacity? It has been presented here. Now you see that for phi is equal to 8 degree, the case is considered to be for the intermediate shear failure as the void ratio is 0.656. The intermediate value of the NC, NQ, and N gamma has been computed. So based on the value of the NC, NQ, and N gamma has been computed, which has been presented here for computation of the shape bearing capacity. So what is the value of the shape bearing capacity for the given data is 10.14 ton per meter square, considering the factor of safety of 2.5. So here this is showing that the shape bearing capacity is coming out to be 10.14 ton per meter square. Now going further, how to compute the settlement of the each layer and how to get the total settlement of the influence zone and how to consider whatever the total settlement is being computed for the influence zone, how to take into this consideration for computing the allowable bearing pressure. It has to be understood here in the today's presentation. So the settlement computation criteria, the various methods are available in the textbook, Boussinesq equation, Newmark's chart, influence factor, etc. Here the new influence factor has been considered. As far as the influence factor is concerned, the M value is 2Z by B, where Z is the thickness of the particular stratum, whereas N is equal to L by B. So based on this, the influence factor has to be found out for settlement computation while finding out the consolidation settlement. Here it has been presented that the groundwater table is at 5.5 meter. The various soil layers has been shown. The soil has been divided into the 6 layers. It has been presented here in the form of layer 1, 2, 3, 4, 5, and 6 with the Roman figures. So you may see that the layer 1 is below the foundation layer is of 1 meter. Layer 2 is of 2 meter thickness. Layer 3 is of 2 meter thickness. Layer 4 is somewhat different in compared to the other soil. It is found to be a silty soil, whereas other soils are found to be a clay soil. So computation of this layer of silty soil the procedure will be different in the it has to be calculated on the basis of the n value. Whereas for the other layers, the values of the consolidation settlement has to be computed on the basis of the compression index, which has to be taken as 0.11 as given in the data. This is showing the incremental stress at the layer 1 delta P1. The influence factor has been found out from the table, influence factor table, which has been shown to you previously. M and N are being calculated on the basis of the 2Z by B. Z is the center of the clay stratum thickness. First layer is of 1 meter. That's why Z value is 0.51 by 2. Hence, the incremental stress for the layer 1 has been computed as 10.05 ton per meter square. Incremental stress for the layer 2 has been computed as 9.49 ton per meter square, and influence factor obtained for the same is 0.936. Similarly, the consolidation settlement for the layer 1, 2, and 3 has been computed. Sigma 0 and delta sigma has been found out. Thickness of the clay layer has been taken into the account as a H. Initial void ratio is E0 and compression index is 0.11. Looking to these values, and as told to you, based on the n value, the settlement of the fourth layer has been computed, considering the n value presented in the Borlaug and which has been given for the silty sand layers. Considering all this and considering the effects of the water table, etc., taking the rigidity factor and depth factor into the consideration as per the IS code, it has been found that the settlement of the foundation, total settlement of the layers S1 to X6 has been found as 123 mm. As per IS code, whenever it is resting on the clay, the allowable settlement is 100 mm. And here, whatever settlement has been computed, it is found out that it is 123 mm. The safe bearing capacity which we have been computed here, it is 10 ton per meter square. So 10.14 ton per meter square. This is the permissible settlement for the foundation for our case. This is the actual settlement considering the settlement of 4 layers. It is 123 mm. So compensating the additional 23 mm of the settlement here, it has been found that the allowable bearing pressure of the foundations has been found out as 8.2 ton per meter square. So considering the shear criteria into the consideration, considering the settlement criteria into the consideration, we have been found that the total allowable bearing pressure has been found out as 8.12 ton per meter square. So this I wanted to convey to you as a part of the presentation, which to be presented to your students. I think that I have been finished the presentation within the time limit of 1 hour and 15 minutes, what you have been given to me. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you.
Sir, on behalf of Chalapati Institute of Technology, we express our heartfelt thanks to Professor Chandresh H. Solanki Garu, Senior Professor, Sardar Vallabh, National Institute of Technology, Surat, sir. In a short notice, sir accepted our invitation to present this webinar, which is very much useful to our students, faculty, and other people who attend this program. Thank you, sir.
Thank you, sir, for inviting me. We'll be in touch. Thank you.
Sir, thank you, sir, for sharing your valuable information.
Karim, shall we close? Or
Okay,
any
thank you.
questions?
Thank you.
Sir,
Sir, the feedback link was provided in the chat. Those who attended the program, fill the feedback link. They will get the certificate soon, within 2-3 days.
all the participants, please check once whether you are filling or not of your feedback form.
Karim, shall we close?
Yes, sir. Yes, sir.
Okay, okay.
Okay, thank you.